Yes? Yay! We did it. We got audio. Love to see it. Okay, so welcome to the stream. We are working on the Merlin more tonight. What are we doing? Well, let's figure that out. So last stream, we still got the ion pump controller from last stream on. For those of you who weren't here last stream, we'll look at that real quick. It's this lovely board, right? Isn't this box fun? Step back into the light. It's the ion pump controller. So we got high voltage on the back. The business in the front, party in the back, right? And it has some capacitors that tried to go to orbit. And they leaked electrolyte onto the PCB. So that's not good. Really, we're gonna get new capacitors for this. So we're gonna set this aside, and we're gonna open up other boxes on the microscope because we gotta fix this. So let's work on our list, shall we? Okay, so this is kind of working. Cool. Let's pull up Logitune so we can get that one camera kind of fixed. And of course, I bet the second I open up the app, it's just gonna fix itself because that's usually what happens. No, it didn't. Interesting. The exposure control behaves so differently depending on just seemingly how it's feeling. I don't know. That thing's weird. Is autofocus set to on? Autofocus is set to on. Cool. We love that. Why is chat not working? I feel like I thought I actually fixed this properly last time, but I guess I didn't. So okay, we'll just pop out the chat, I guess, and have to copy the link manually every time. That doesn't make sense. I feel like I should be able to do this without copying the link every time. There we go. We got chat. Okay, we got chat. We got a note. So let's just move this cart aside so we can kind of see the microscope and I can point out where we're going to be working tonight, and then we can come up with a plan. And also, you all in the chat, please feel free to let me know what part you want to see first. So we can do either, we'll probably just start with the part that's right here, because it's right here. Huh, I just noticed a little piece of plastic, I guess. Okay, well, at least it's not a piece of metal. So we're probably going to start with this box here. This box here is the stage controller. So that is water cooled. It is going to be a bunch of transistors, possibly some resistors and whatnot, all attached to some heat sinks in there. So that'd be kind of cool to see. Once that part's done, we're going to rotate the microscope about 90, maybe 180 degrees. I don't quite know yet. And then we're going to be working a lot on this side of the microscope. So what's going on over here? We've got the static optics control board. We've got the dynamic optics control board. We've got the scanning board and then the hardware controller. And the hardware controller kind of takes care of the vacuum sequence, puts the detectors in and out, kind of it's where all the CAN cables connect to. So yeah, let's figure out our plan here. Welcome to the stream, Maria. Good to see you. Okay, let's see here. Let's pull up the note. Pop that back in. I'll put this window over here so I can see what y'all are saying at the same time as I'm working on the note. Oh, and then I need to give you all access to the note. So there, oh, forgot that paste doesn't work in OBS because weird things. Okay, there we go. There's the note. So what are we doing tonight? We are to do external inspection. Oh, inspection, and photos of stage controller. Open the stage controller, internal inspection, and photos of stage controller. Assuming all goes according to plan, I guess we're gonna clean it out. And then we're going to close up stage controller. So let's actually, all this is gonna be, well, let's do this. Break this into sections. And then I guess we're basically doing the same thing for each of these, so these don't need to be specific anymore. Look at this, organizing. So we got, assuming we don't find anything wrong, we basically have 5 things to do for each thing. Oh, excuse me. Let's see here. Scanning controller. Why is that first one pasted? Well, I have theories about why that first one's pasting weird, but that's fine. Hardware controller. Okay, so that is quite the list. Is that an ambitious amount to get to tonight? Potentially. We will find out. What do we think, chat? Think we got it? You think it's a lot? I don't know yet. But we're gonna find out. Okay, let's see here. How are we doing on the stream? Can I get a audio video check from one of y'all? I always love knowing if y'all can even hear me, you know? Okay. So I think we got a pretty good plan here. Audio's good. Love to hear it. Let's see here. Did I finish the Mastodon post? Let me make sure I finished the Mastodon post. I think I did. Audio's good. Video's good. Wow, we're doing great. What could possibly go wrong? I shouldn't say that. I should not say that. That's a terrible idea to say. Okay, I think we got all of our posts up too. We need to automate that. That would be good, right? Don't we love automation? Famous last words. Yeah. I need some wood to knock on. Okay, so I guess we're gonna just start with the first thing. And let's get the camera set up for some photos. But we'll do a quick video tour first of what we're looking at. So this down here, that is the stage controller. Big old box. And on the left side of the stage controller is where all of the connections for it are. So what kind of connections do we got on it? Well, I know that we got power going to it because we worked on that power supply earlier. So we got power at the bottom here. We've got our fiber optic can. That's always fun. We've got a ground cable, it looks like. Does that go to the inside? Nope, it goes to the outside of the box here. It looks like there's an extra fiber optic port, unused, labeled B3. That's interesting. And then, yeah, we've also got the water cooling block on it. That's kind of on the bottom edge here. And yeah, so we're going to be... So my intention is to try and leave this attached to the microscope. I don't know if I'm going to be able to do everything I want to do with it fully, with it just left being attached to the microscope. So we're gonna find out. And we're gonna find out once we open it up. So let's before we open it up, we want to get some good pictures of our connectors, so that if we end up having any questions about how this thing went together, we can relatively easily answer them. So there's some more views of the connectors we're looking at tonight. We got fiber optic on the bottom there. You can see the water cooling block. That brass or copper maybe. I think that's, doesn't quite look like copper, or maybe it's just the alloy that it is. Fiber optic can in the front, grounding. And then if I had to guess, I'd say that the cable on top, that's probably the power supply, and then all of the ones on the bottom are what actually go to the stage. And you know, I don't think we've actually shown the stage on stream yet, so we can do that real quick. So this is the microscope chamber door. On the left here, we've got this big connector here. This one's rather satisfying connector. Look at all those pins. Isn't that fun? Very high quality connector they used here. Yeah, just check out all of those pins. Okay, maybe if it would focus, that'd be great. There we go. Look at that. So that's a vacuum feed through. So everything that's on the other side of this connector, that's all in vacuum. Okay, that's fully seated. And then on the outside, we've got another two axes of our stage. So this one's going to be the Z-axis, this is going to be the tilt axis. And we'll see how that all works once we get our door opened up here. So here's the stage itself. Like bring a light around for it. So there's the stage itself. So this is a 5-axis stage. So the sample slots on right there. The part the sample is on can rotate. On some microscopes, that part also goes up and down, the round part the sample is on. This microscope is a 5-axis stage, not a 6-axis. If it were a 6-axis, there'd be a sub-Z-axis, which there's not on this one. And then that rotating part is mounted to an X and Y table, so that gives us another 2 axes there. And then you can see in the middle, those 4 bolts, those 4 big bolts there, that is what bolts the stage onto the pivot point, or to the pivot bearing. And we've got a big kind of worm drive there on the side. And so that worm drive on the side there, that is driven by this motor on the outside. So these 2 axes, so tilt and Z-axis, those are driven by motors on the outside. And then everything else is driven by motors that are in vacuum. And then so this entire thing, the tilt axis, XY axis, and the rotation axis, that all moves up and down on the Z-axis on the door. So we can see the linear rails that make up the Z-axis on the door right there. I think there's one of the tilt optical limit switches right there, maybe. I don't think that's Z, I think that's tilt. You can see the one of the bearings. There's some exposed roller bearings on the stage tilt, or stage Z-axis there. And then, yeah, we've got various D subs used for hooking stuff up on the stage. We've got another optical limit switch you can see there for one of the, I believe that's the x-axis optical limit switch. And then something that's important in an electron microscope is that you don't have exposed insulators in the vicinity of the beam, because it'll cause charge up and deflection and kind of all kinds of weird effects. So we've got all of our stage drive cables are shielded by these springs. And then for stability reasons, the stage actually makes contact with the very far side of the chamber. So you see those marks up and down? That is from this part right there. So that's another kind of tilt, or that's another pivot point to help stabilize the stage. And that pivot point basically slides up and down on the back of the chamber wall. And that's just so that instead of this whole thing just kind of being this really long lever hanging out that could like vibrate up and down like that, it's got support or vibration dampening, I guess, kind of on both sides to help stabilize it more. So yeah, so that's the stage. That's what we're driving. So that's what that box controls. And yeah, we are going to get set up here to get that box opened up. So let's we're gonna switch to photo mode briefly, just so we can get some pictures of the connectors, pictures of the outside of the box, make sure we know where everything goes, in case we have any questions when we go to put it back together again. And if you all have got any questions about it, please feel free to put said questions in the chat. Okay. Let's see here. What do we got? We need to go to that mode, except that mode is not working currently. Why is that mode not working all the way? It's because the application the application that it's supposed to be screenshotting is here. Is it because it's on the wrong window maybe? Hey, there we go. Okay, cool. So we got that. Let's put the camera into tethered mode. So I gotta unplug it. We're gonna swap USB cable. Nah, this USB cable is fine. This cable is just fine. Let's put it, it's strange because we know tethering mode is always a little bit sensitive. It's like the UVC seems to care a lot less if it disconnects briefly. It just picks up where it left off. Tethered mode, it like freaks out. It has to re-index the SD card on the camera, and then we gotta like end up waiting a while. So we're going to put the cable on some strain really from the get-go here. And then let's go, okay, we actually do have to unplug it so that we can get it out of UVC mode and set it to photo import remote control. There we go. Okay, it's indexing, so it should show up any second. Hey, look at that. Okay, and then press that button, get that view. Hey, there we go. Let's do view. How do we just get it to fit? What's the button for that? There's a button for that. Ah, there we go. Okay. And I think it will automatically go where we want it to. We're gonna find out if it automatically goes where we want it to in terms of photos. So let's get going on photos here. Actually, we're gonna do one other thing first. We are going to do a lens change because I know we're gonna be taking pictures of connectors, and taking pictures of connectors with a lens with such a long minimum focusing distance is challenging. So that's why we're going to switch to something with a much shorter minimum focusing distance. Okay. I think we're good to go. So, can I get the store open any further? No. door is hitting something. Ah, it's hitting the bolts. So this is definitely as far as we can get this door opened. And I just realized we are going to be a lot better off here if I bring some more lighting in. So let's do that. I mean, we certainly got the lighting to bring in, so. There's some lighting. Okay. So on top here, we've got a connector. No way. I'm so surprised. Let's stop our aperture down a bit more just for that little bit of extra depth of field. Is it possible to read a label on this somewhere? Oh, they hid the label underneath. Oh, just lightly bumped my head on the frame. I should be careful of that. Really, not exactly appreciating where they put the label for this connector. They could have made it, I guess they could have made it harder to read than this, but. X211, okay. Cool, so now we know where that one goes. And then I'm guessing that all the other connectors are gonna be equally terrible to read. They are. They are bundled up quite tightly here on the edge. So we can kind of see how the hinge is intended to work. And then something I am noticing is this this fiber optic CAN cable down here. So there's this one here, right? That's not connected to anything. That is labeled B1, B2. And I bet that says stage box on it somewhere. No, it doesn't even say stage box on it. But I'm pretty sure this was a stage fiber optic cable and was for some reason taken out of service. And they put a new one in, and they just kind of shoved the new one in here. Like we can see the new cable just sort of loops around on the ground there. I don't really like that because of what that's going to do to the cable on this end here in terms of strain on the fiber optics there. So that's going to be something that we address. And let's document which one. So the black part of the cable, that's B2. Okay, good information to keep track of. This one's got different fiber optic connectors than most places on the microscope. I don't remember what the name of these ones are, but it's a little bit easier to work with than the snap-in ones that we've been dealing a lot with. Oh, somebody's conveniently put a Sharpie mark for left and right on these cables. So that tells me there's a decent chance these have been pulled off for some reason. If the cable's been pulled off, and there's also a decent chance that this box has been swapped out for some reason. So here's the heat sink water cooling connection detail on this microscope. I am a pretty big fan of this microscope's heat sinks. I think they are pretty decent, especially compared to a lot of other heat blocks I've worked on that have had like flatness issues because they were just made out of like a square tube instead of a piece of stock like this. Like they were formed instead of machine and they aren't flat, and then the devices don't sit flat on it, and then the devices overheat, and it's just not, it's just a problem. It's just a whole bunch of problems. Let's get a photo that kind of shows how our cables go up from this box, because we are going to be opening up the bundle in order to add, oh, I got the cable in front of the camera, in order to add the currently loose fiber optic back into the bundle, or even if we don't add it completely back into the bundle, which we might do, we're still going to get it into the bundle enough so that it's hinged properly on the door and less likely to spontaneously, or not really spontaneously, I guess as a result of being flexed back and forth in an unfortunate way, be broken. So I think that's just about all the cable documentation we can do. We can't really see the labels on most of these. And I think these labels that are further down are mostly part number labels and not connector location labels. I think the connector location labels are pretty much all on the connector themselves. So yeah, that's the, I think we can, oh, and we do have a number on this box. Let's grab a picture of this number real quick. And let's grab some pictures from just a little bit further back so we've got something kind of for reference on, we can point to. Oh, this is the box. Good job, autofocus. You figured it out in the end. Wow, Capture One seems to be doing really well tonight. At least they are consistent. Yeah, you know, consistency is nice, right? At least they are consistent about what, though? I wasn't looking to see when you made that comment. Now let's check out the mounting hardware. So the mounting hardware for this is kind of interesting. They've put these pieces of heat shrink over all of the screws, I believe in an effort to prevent you from being injured by them. Ah, yeah. Labeling the connectors does make it much easier for next time. Okay, so I think that concludes our first work item, so we can get that checked off. So let's reconfigure for video mode here. Unless, of course, there's any part of what we just looked at that any of y'all want to look at closer. So in that case, we can always revisit that. Hey, no problem, DJ. No problem. Love sharing microscopy with people. Okay, let's see here. To do. Well, actually, we'll just start at stage controller. Fit as much on screen as possible. Okay, back to video mode here. Yeah, no, it's been really interesting lately. Like when I was first doing this on stream, I don't know, 7 or 8 years ago, you know, I'd be sharing my microscope and people would be like, oh, that's cool, right? But now I'm getting like a lot of people in the chat who are like, hey, I've got a microscope too, and I'm learning about my microscope too. And we're talking about their microscopes too. So it's like, oh, wow, the community's really come like quite a long ways in the last few years, especially, it feels like. So a lot more people have got electron microscopes at home now, and it's really cool to see it happening. Whoa, all my windows just freaked out. Okay, so we've got our photos taken. Let's switch to video mode here, which I didn't do on the camera yet. That's why we've got a big blank spot in the middle of the stream at the moment. Okay, there we go, UVC mode enabled. Okay, let's get some lights arranged here. So we're going to start out just with the flathead driver, it looks like. All we're going to need, I need that first. I'm going to grab a different tripod, one I can kind of get more up close and personal with, to all the electronics down there. And we'll go ahead and extend the articulating section of this one, I think, tonight. I love tripods that have this like arm that comes out in the middle. It's really great for getting just the right angle, you know? And yeah, I'd love to see it. Okay, and then I always gotta remember to lock down the rotating part. Otherwise the camera just rolls over. And that could be bad if it accidentally hits something, so. We'll just plop that down there. And let's transfer the camera over. Do I want to stick with the macro lens, or actually I'm going to switch back to the zoom lens. That's going to, I think, work better for the work we're about to be doing here. There we go. That should be bright enough for y'all to see stuff now. So are any of y'all working on anything fun tonight? Are any of y'all working on your own electron microscope tonight? Okay. Let's grab our driver bits. Oh, we need another screw container, because the one I got out is dedicated to the ion pumps we took apart last stream, and I don't really want to like mix up ion pump screws and stage controller screws. So I'm going to go grab another acro bin. Well, I'm not immediately seeing any empty small acro bins. Well, we have the tape measure bin. There's no tape measures in the bin right now, because apparently they're all somewhere else. So we'll steal that bin. That should be fine. So when you see the tape measure label tonight, just think screws. You know, it makes complete sense, right? Oh, hey, you got a Joel. Nice. Love Joels. So I started out with ISI, which is another Japanese electron microscope manufacturer. RIP ISI. They are no longer with us, but my second microscope, and much more powerful microscope, and one that I did a lot more work with instead of on, was a Joel, and I've got the rest of my workshop here. The other 1,700 square feet y'all can't see right now. That is full of a bunch of vintage Joels, and I really like them. So yeah, 6480 is a great scope. You'll have a lot of fun with it. And the LV on it is nice for several reasons. Okay, let's start popping this open. I will say, very shiny sheet metal, Zeiss. Well, moderately shiny on this box, but then you look at the boxes like that are back here, and these are incredibly shiny. I don't feel like I see a lot of, not a lot of other manufacturers make stuff that shiny, so it's kind of cool to see. Ta-da! It's the same board as Sigma. Of course, it's the same board. It's a Sigma stage controller. Okay, we're familiar with this. We're very familiar with this. I mean, okay, it's not a Sigma. It's a Zeiss stage controller, but they just took the same, basically the same board as everything else and shoved it in a box. And I am just saying that at first glance. I'm sure if I look at it more, I'll maybe find some more differences, but. And I do actually see some differences now that I'm looking at it. But I mean, I could actually open up Sigma right next to us, and we can compare it. Hey, welcome to the stream, Monochroma. Good to have you. Monochroma, meet DJ. DJ, meet Monochroma. Y'all both got SEMs. So, DJ, we got to get you into the SEM hackers Discord. And vacuum hackers, but SEM hackers especially for your microscope. It's a great Discord community. Are you in SEM hackers by chance currently? So let's go just free-handed here a little bit. Let's bring a light down so we can see inside better. Ah, you are in there. Sweet. Do you have a channel for your microscope currently? Not there. Okay, so here is our stage controller. So, stage cables, they'll kind of hook up in the middle of the board. And then, this is fun. Every single channel has got its own FPGA and its own memory and some other stuff. So yeah, there's a lot of digital electronics going on in the stage controller on these microscopes. A little bit more than your Ramps 1.4 for your older 3D printer or whatever the current boards are these days. Oh, important checklist item we should put onto everything. If one of you all wants to edit the note, I'd be very appreciative. We need to make sure that for stage controller, the static optics board and the dynamics optics board, we need to make sure that the temperature safeties are installed properly. If temperature safeties aren't installed properly, we could get an overheating issue and not really know it, not really realize it. So like on this board here, if I'm not mistaken, I don't think this one has a dedicated temperature sensor on the heatsink. I think it just relies on the main one. I'm not 100% sure. So I need to investigate that. I know that those ones do. We want to make sure that that's actually properly mounted to the heatsink. The water cooling loop on this microscope is all like linear, like it's just one loop. There's no like split loops. So we can pretty much rely on our flow switch, relatively, rely on our flow switch and our temperature sensor here. I kind of thought there was a temperature sensor in here somewhere, but anyways. So top left corner here, there's going to be a big FPGA under there. And then Zeiss does this on a lot of their microscopes. There's a bunch of pins that surround the FPGA. And so if they ever want to do some kind of mod or some sort of future mod to the board, there's kind of a dedicated place to be able to relatively easily do that mod. And you can see in this case, they are using that board to great effect. So it looks like we got a couple of relays on that board. Don't really know what they're doing. So we got a relay there, cable plugged into it, cable comes all the way over here, and then nice. That is actually, so there's some pins there for that cable that goes to. So there's something going on with that. Looks like there's actually 3 cables, a couple of relays. There's an LED there. So that's they're reconfiguring some stuff in some places using those relays. But that's not there on the Sigma version of this board. We got all of these ceramic resistors here. A lot of electrolytic capacitors on here. I don't anticipate as many issues with our electrolytic capacitors on this board because we've got this lovely heatsink here. So this really does help keep the temperature under control in this area. So that's great. Yeah, we got our fiber optics. So these are just like bulkhead fiber optic connectors. I mean, if we yeah, like it just comes off both sides. So that's interesting. Looks like these are all soldered. No crimps in sight here. These are like hermetically sealed D-subs, which is kind of funny. I think it's funny because there's holes in the lid for the enclosure. Like, got the hermetically sealed D-sub, and then we got just holes. So they weren't doing that to keep the moisture out or keep the air out. It may be because they're more robust, honestly. Like these are a little bit of a nicer connector than stamped and formed and inserted into a back shell or like that. What else do we notice? Yep, that one on the top, that is definitely our power connector. It's one of those D-subs with the really big pins on it. And that comes over to the, I believe, mate unlock at the top of the board there. We got big ol', is that a Litz wire? That might be Litz wire for our ground there. And then that's probably just gonna go to like, yep. So we got this really nice Litz wire ground, and it goes to a 1/4-inch spade, which is universally recognized as one of the lowest inductance ground connectors out there. I'm joking, it's not. But A for effort. And then, yeah, it's this Litz wire, and then it's quick disconnect on that side. Oh, look at that, look at that. Loose ground. Come on, autofocus, you got this. You got this. There you go. Very, very exceptionally loose ground. We have found so many loose grounds on this microscope. It's not surprised. Okay, another checkbox. Check the grounds. I'll add that in a second if nobody gets up before I get back to the monitor. So yeah, I do appreciate how the clamping on all of these devices works on this one. we've got individual clamps for each and every device, which is great. On other parts of the microscope, we've seen devices clamped to heat sinks with like one large heat spreader, and that can cause a variety of issues. But with individual clamp, you get like just the right amount of clamp force on each device, and each device gets held on like level onto the heat sink. So that's great to see. As I mentioned earlier, I've been pretty happy with how the water-cooled heat sinks on the Zeiss platform works out. You know, every platform's got some stuff I like and got some stuff I don't like. The heat sinks are on this platform something I definitely do like. So yeah, we can kind of see the channels per stage, right? We got FPGA at the top, some memory. I think there's some DACs. I'm trying to remember. I think those are DACs. I think there's also, the like motor driver, right? I believe those are some op amps down there. Those red cylinders, those are fuses. The fuses, I'm not too upset with. The fuse holders, I've had issues with the fuse holders, where the contacts inside the fuse holders fail over time, and then you get intermittent connection. So you pull the fuse out and the fuse tests fine, but the circuit still doesn't work. You're like, what's wrong? What's going on? Right? It's like, well, no, it's the fuse holder. So yeah, that's what we're looking at here. Just trying to get footage of the whole board right now. And if anybody sees anything that catches their eye or they want to take a closer look at, please let me know. See if we can kind of look at the bottom here. So it looks like we'd actually, okay, if we want to check out the back of this board, how involved is that? I think the answer is very. So I thought that this might just be a panel on top here, but I'm actually, on second look, yeah, it's not a panel, it's folded. So you actually have to mess around with the heat sink down here too, because it's just went through that corner of the box. So if you want to get this out, you got to take the fittings out like completely from this end. Because you can kind of see how this comes out of the box and the fittings are sticking out too far. So it's not trivial to get to the back side of this board really. I don't really have I don't have that many concerns about the back side of this board. I mean, we could like check on the soldering on these connectors, which should be pretty okay. It's not made by the same company that made the ion pump power supply, so that's good. So yeah, I think we're going to switch to photo mode here and continue our inspection. But that's a tour of the stage controller on this platform. Yeah, thermal safeties. I love disabling and bypassing thermal safeties. Yeah, Litz wires are the worst ground implementation. Isn't that pretty funny? I thought it was funny. But yeah, no, like they did a really nice job at the ceramic. Ceramic resistors, ceramic insulators, so it all stands off. It's away from the board. Yeah, right. Individual FEGA RAM flash per chip. The ion pump power supplies are not in the trash. We are likely using those ion pump power supplies, so you know, yeah, it's gonna be great. It's gonna be great. Everything's gonna be fine. Everything's gonna be fine. Cool. Well, yeah, I'm going to switch over to photo mode here. Choose USB connection app. Photo import / remote control. Plug that back in. Oop. I'll set that down for now. DJ, I got a link for you. I'll post up. Are you on Discord, DJ? Let's see here. There we go. That's what we want, right? If you want, you can post your Discord username in the chat here, or I can try posting links. We've had issues with the invite links in chat, but we'll try it out. There's one of them. So that's the SEM hackers. And here's vacuum hackers. Okay. Let's get some photos going here. I want the macro lens. 35mm macro, that's worked out really well. I've been pretty happy with it. It's got a 0.5x magnification ratio, which is pretty good for 35mm. We'll just set our other lens inside the SEM. Nothing could possibly go wrong with that, right? What could go wrong having our lens there? Okay, cool, it worked. So on SEM hackers, go to the introduction channel, introduce yourself, mention what microscope you have, and ask them for a dedicated channel for your microscope. And then you'll have a place for you to post what you're doing, ask questions. And there's a lot of people in there who've got a lot of experience with SEMs, so it's a great resource. Okay, let's get some more light going. Let's get this one closer. Gotta stand up to hit the release on that. Love just surrounding myself with all the soft boxes. It's pretty great. Especially with the days this short, you know? I feel like this is good light exposure therapy or something. It also helps to illuminate something or a box like this without any shadows. Okay, one of these two carriages doesn't like rolling very easily. I need to figure that out. Come on, where's the release? There it is. Okay. Got a lot of cables to work around here, so that's gonna be fun. So yeah, underneath that green board there, or that daughter board, or mezzanine board, I guess, is where the FPGA is. I believe that's the RAM for the FPGA, RAM and flash for the FPGA right beneath it. So I believe, if I remember correctly, and the labels appear to be backing me up here, the top two connectors are the limit switches. And then the bottom connector is for the motors. Please focus. There we go. So yeah, you can see up the upper and lower limit labels. And that's for like, yeah, that's gonna be optical encoders or physical switches. I think on this one it's all optical. And then this lower one, I think that one says stage motors, if I'm not mistaken. Yeah, stage motor. We got our can up here. Oh, that's funny. We got a dedicated boot OK fiber. The amount of embedded stuff going on in the Zeiss platform is kind of insane. And then what's this one over here? Alarm. Ah, yeah, the alarm circuit. Touch alarm. I can there's certainly some stuff on here that's works the way it does because other microscopes that came before it worked the way that they did. Oh, please focus. Touch alarm. There we go. Okay, what other connectors have we got? We got a lot of little ones that go various places and do various things. Yeah, boot OK fiber, kind of amazing, right? I do not stream in ultra low latency mode. I could try that out. So we're kind of doing our overview pictures now. So I haven't actually done this myself, but I've been told it's relatively easy to swap stages on Zeiss's, like not just change out one stage for the same type of stage, but actually change what type of stage any one particular microscope is equipped with. It's pretty much, you just gotta select it in software, set the jumpers on the stage board, right? And then all the connectors are basically the same is what I've been told, more or less. Or, well, it's more that, this is kind of an adapter box with the connectors on the outside here. Speaking of connectors, let's get some pictures of the connectors. Yeah, snoot boop alarm. Snoot boop, oh, love the snoot boop alarm. Really saves your bacon occasionally. Well, there's a loose connector, slightly. I think that's loose. It wasn't really, but it wasn't quite all the way in, but it also wasn't loose. It wasn't an issue. So you can see all of the unused zip tie clamps on the heatsink here. I don't even think the geometry really works out to have these zip tied down. You guys don't really need to when you got this big old box here. I'm pretty sure this box is the dimensions it is basically because of the connectors. I mean, if we look at it, like the connectors are basically taking up all the room, like this side of the PCB, so. That Litz wire ground going to the quick disconnect is still really funny to me. So what do y'all think about the lack of a fuse on this channel? We do only have a 5-axis stage in the microscope currently, so if I had to guess, and I am just guessing, I would say that probably the 6th channel on the end here just isn't used, but it is still kind of funny to me that it's missing a fuse. I wonder if a fuse blew somewhere else and they're like, well, I know where a spare is, and they got a spare from the 6th channel. The 6th unused channel, hopefully. Again, this microscope was working when it was deinstalled, is what I was told, and I have a video of it, so I do kind of believe them. It's more than likely that it was working. There's our thermal safety. Like I thought it had one. It's right down here on the end. So those blue wires you can kind of see. Looks like it's making pretty good contact, but I'll have to get my eyes on that. It's gonna be really hard to see with just the camera. just because of the angle it's all at. So you think we're going to find any more AI-generated heatsink clips tonight? That was funny, wasn't it? But I think I'm pretty confident that this thing is a little bit better built than the IGP supplies were. Are all the flash ICs the same firmware? I do not know if they are all the same firmware. Yeah, I am going to be looking for FOD, foreign object and debris, in the bottom of this box. Do not intend at this time to pull the PCB off, which is not trivial to do with how this whole thing, with how this box works. So yeah, we're gonna vacuum this out. It's pretty clean, but before we do that, I think we're just gonna look at everything really closely, which we've been doing, but I can get up close and personal with it a little bit more than I can get the camera in there. Wrong menu. Choose USB connection at video call streaming set. Okay, let's go. Okay. Majority of labels are the same? Oh, that would make sense. I haven't dumped firmware on these. Maybe I should do that at some point. Wow, I've had 71 people view the live stream so far. That's a lot. Okay. Oh, you're asking if all labels are the same. Yeah, we'll be able to check that in a sec. Okay, what are we doing? So we got photos of it. I'll just throw one photo in the Discord for you all to look at. And also, and just for you, Monochroma, I will also throw a picture of the, I will also throw a picture of the flashes in. So we're going to export that one. Throw that one in. We'll do one of the far end too. There, that's a pretty good one. Where's the JPEG? There's the JPEG. Let's just level that one real quick. Lens distortion correction just stops working once you get HDR mode running, because HDR kind of crops it a little bit. So then the software doesn't really know what to do with that, which is unfortunate. Okay, so these should all be marked. So we can go library, sort by 5 stars. I only got 4 pictures that are 5 stars. Okay, I must have missed something. I missed one of the pictures I wanted. I missed. There we go. Okay, let's get all those exported. Come on, select all. There we go. Okay, export. Export. Yeah, I know you want to know what this copy paste cluster is made out of. That's why I'm getting these pictures up. And keeping the quality high on them too. These are not IGP supply. These are Merlin FEG SEM stage controller. And you know, we're just gonna leave them in that folder. That's fine. Changing folders is annoying on stream. Encoder overloaded. Is right now, are we getting like a little bit of slideshow? I mean, I am exporting images from Capture One, and it seems like when Capture One's doing stuff, that's when we've had the issues with like encoder overloads in OBS, and things have gotten kind of slideshowy, if you will. So I'm very curious if that induced the issue. Oh, it did make a folder. Well, it labeled the images wrong, but at least it put it in the right subfolder. Okay, have at it. There's there's the pictures, and I'm a little bit curious too. And please feel free to post whatever you find in the chat. And if there's something you need a better picture of, I probably have it. And you can tell me to post it, and I will. Okay, so that's going to conclude the photo section for now. You're just listening to this stream until V7 opens? That's a mood. Oh, man. There's people who know what V7 opening means and people who don't. I feel bad for people who don't. So V7 is the column isolation valve on 1980s era Joel SEMs, such as the 840, 6400, 6300, 6300F, 6320F, 6400F, 6320F, 6330F, 6320F, sorry, 6340F. I think it's even on like 6700 and 7400. I think it's also V7. It's just V7 all around. Okay, so for those of you who are in the Discord, I just posted the pictures to the Adamant Cones Merlin FEG channel. And yeah, let's go stare at this thing really closely. Really closely. Okay, let me get a flashlight. There's a flashlight. Wow, I'm impressed that that's not like flaring more. Oh, there we go. I do this with the webcam. The webcam won't like that, but yeah, a little bit different story between these two optics, right? Let's try the let's see how the 6D handles it, or the R6. Oh, it's decent. It comes down to the lens I'm using too. And then I got another inspection flashlight. We're gonna look at this thing so closely with so much light. Okay. Hi. So what are we looking for? We're looking at connectors, we're looking for FOD, we're looking at capacitors, we're looking at resistors. Now I want the bar style, I think. More diffused light. So these 3-pin cables go into these relays here. They're pretty funny. They just, the middle pin goes to common, and the pin 1 goes to NO, I think, and pin 2 goes to NC or something like that. Oh, there's little phenolic insulators on the mounting hardware. That's kind of interesting. It's probably for the grounding architecture reasons. At least on the top side, the thermal pad looks to be in pretty good shape. You see any FOD on the bottom here? Well, all of our fiber optic cables are latched. That's good. Okay, let's get a little bit lower here. Huh. That's a suspicious solder ball. It's only one, so that's good. Fire the photon torpedoes, yeah, exactly. Okay. Glad I mopped recently. Huh. This is going to be visible in the pictures. If you look at, what is it? It looks like the second channel from the left, V35, which is the jumper. It looks like something hit the jumper and bent those pins all over the place. Okay, let's check every electrolytic on the board. That's what we're gonna do that now. These are 50 volt, 47 microfarad electrolytics. I haven't found anything that's not that yet. And these ones all have the, very kindly, have the pressure relief pattern on the top, or grooves. Okay, these are all looking in pretty good shape. Hey, we got some bodge wires in the top right corner. That's fun. Oh, we got bodge wires and we got an SMD resistor. Oh, there's some fun bodges going on there. Okay, all the capacitors look like they're in good shape. That's always welcome. They're like, these connectors they use are not quite meant for these pins, but they're working, I guess. Lightly touching each of the fuses just to see if anything feels especially loose. On ones I've had issues with, once you've touched them, it's been pretty obvious. But the issues I was having was voltage wasn't making it through at all, so. It's a little bit dusty in here, but it's not terrible at all. The through-hole soldering quality looks excellent on all of the devices on the heat. It looks really good. I don't see any exposed pad on top. Not perfect fillets everywhere. Well, okay, there's one. Oh. That's interesting. Is there? Okay, there's one pin. Everything looks great, except for, oh, no, it's the middle pins that I can't see that easily. The middle pins are not soldered as well, presumably because the middle pins are attached to the heatsink, so those did not get as hot. And it looks like it's basically the middle pin on like every single one is not soldered as well as the other two pins. Any debris or anything down here? What was that one little solder ball we noted earlier? There's no fuse down here. Is that a solder ball? What is that? That looks like a solder ball. Okay, let's check out our connectors. So solder cups on all of these on the bulkhead over here. It's all shielded cables in this box, so that's cool. Hey, we have a board with a Leo silk screen on it still. Oh, I gotta make sure I get a picture of that. That's funny. A Leo silk screen still. That's great. They do not rev the PCBs. They just bodge wire them on average. Okay, I don't see any issues with the connection on this side. Let's check out these ones in the middle here. Well, they've done some creative things to fit 2 wires on 1 pin in a few spots. But, is that pin all the way in? Okay, what is that? Pin 14? No, that's 13. Okay, pin 13 might not be in all the way. Ah, god damn it. Ah. Ah. Fuck. There's a broken wire. It was barely hanging on. It was barely hanging on. I just lightly touched it. And it's pin 14. It's the one that they shoved 2 wires in on. Oh, man. Okay. Well, this just turned into a project. This is why you inspect the wire harness, so that you find stuff like this. You're just not happy when you do, because it's not going to be fun to fix. There's not a service loop here. This is going to suck. It's just a limit switch. It's only a limit switch, right? Who cares about a limit switch, right? Who cares about a limit switch? We don't need limit switches. What could possibly go wrong from having a limit switch with a broken wire? God damn it. And it's because they tried to shove 2 wires in 1 pin. I think I'm gonna fix this without pulling the pin out. I think there's like, okay, I have a better idea on how to fix this. It's actually gonna be more reliable in the end, I think. And the ground cable is loose on this connector, but that doesn't really matter because it's gonna have to come out because we're gonna have to fix it. Okay. I'll show you the picture of the one that broke. This one's not going to be fun. I hope you all enjoy my suffering. Okay, I'll show you the picture of the one of what went wrong. Yeah, at least I found it, right? It's better that I find it now than it break later. I mean, if I hadn't have touched it, there was like 1 strand holding on still, you know? It would have maybe been okay. Maybe. Probably. If I hadn't opened this box and I hadn't at all moved the cables, it would have probably been okay. But that's... I always move the cables. I'm really good at very precisely breaking microscopes until they're reliable. Okay, I'm pretty sure I got a good picture of this connector. Okay, so it's this connector right here. It's the upper limit connector, X37. But I need a picture of it from the other side because that's where we'll see the pins that we are messing with here. So it's kind of hard to tell in this picture because it's blurry, but you see how there's that 1 wire that's like jumping over? So that actually it jumps once, and then it jumps a second time, and in that third pin it goes into a wire that comes from the cable that comes from the stage is also going into that pin. And those two wires in that pin is like I could see the pin wasn't all the way in, and the insulation on the wire that broke was like coming off a little bit because it was like they tried to like force it into that pin, and I just the lightest little touch and the wire popped right off. So that was suboptimal. I probably have a good picture of this. Yeah, it's that little bit of white right there. That is the wire that broke. I'm pretty sure I got one from this other angle. There we go. Okay, there we go. Yep. Okay, once that loads. Yeah, okay, so it's, yeah, that's a good picture of it. Cool. So we've got pin 15 here, bottom right corner. Okay, so pin 15 loops up, goes to pin 14. Pin 14 has two wires in it. You're not supposed to do that on D-subs like that. Oh no, you're right. They're not FEGAs. I forgot about. Okay, I had yeah. They're like, and they got like all kinds of like DSP cores in them too, right? So they're using like the DSP cores as a motor controller basically, if I'm not mistaken. Okay, so pin 15 jumps up to pin 14. Pin 14's got two wires in it. Pin 14 jumps up to pin 13. Pin 13's got two wires on it. You can see the insulation on that white and black wire. That's the one that comes from the stage. You see the insulation's like torn off there? That's just evidence that this thing was not supposed to be shoved into a pin with two wires like this. And that is the wire that the second I touched it just like snapped off. Like I didn't even bend it back and forth like once or twice. I didn't even like really bend it back and forth. I just like pushed it a little bit and it went tink. I don't know exactly what that does, but it is on the limit switch connector, so we can imagine what would happen without the limit switch. Is this the lower limit or the upper limit? I think this is upper limit, right? So it might not have caused a homing issue because it only homes to one side, right? But if we lost indexing, we could have a collision. So we might have just gotten lucky that it wasn't on a side that would cause. This is the upper limit. So I think, well, actually, some axis home upper, some axis home lower. So it's just not good form, you know. Not good form to have broken wires on your limit switches. Pop goes the weasel. Exactly. Oh, hey, welcome to the stream, Peter. Good to see you. Yeah, so those fuses, they do move slightly with the poke. They just, I mean, your teeth move slightly if you poke them hard enough, right? But like a loose one's loose, you know? Yeah, so, okay, so that's what's going on with that. We're going to look at all the other connectors pretty closely too, but my plan, it seems like this jumper wire that's installed right here, this one that goes from pin 14 to pin 13, that seems like it's in there pretty well. I don't think I've got issues with that one right now, so I'm going to cut the insulation back on that one, or maybe just cut this one in half, this jumper, and solder the white and black wire, because I don't have enough length on the white and black wire to restrip that and crimp that. And I'd also have to restrip and crimp the black wire, and have to make sure I have the right pins for this back shell, and I don't want to put two wires into the back shell. Like clearly that already failed once. So we'll leave one wire in the back shell, we'll do a solder splice, we'll put heat shrink over it. I think that's probably a good plan, unless anybody in chat has a better plan. Definitely always looking for feedback, but yeah. So that's the story of that one. Before we start pulling that out and soldering everything, I'm going to get back in there and Continue an exceptionally close visual inspection, but before I do that, I'm going to add some more checkboxes because we found things. Repairs. Ground, pin 13, upper limit switch. Wire broke off. I'm doing, okay, wire broke. Upper limit switch, pin 13 had 2 wires going into it. The black and white wire that came from the stage broke off of pin 13. There really should not have been 2 wires inserted into pin 13 from the start, and that's what caused the failure. Going to splice to the wire going to pin 13 instead of trying to shove both of them back into pin 13. I was dictating my note. Just things you find in extremely high cost, low production. Hashtag indeed. That's, yep. These are just things you find in extremely high cost, low production machines. Although this board is used in a lot of these microscopes. Like this is a relatively common board. Okay, cool. Let's get back to our inspection. Did I note everything I wanted to fix? Oh yeah, we were going to also check our. Oh, somebody added check temperature safety installation. Thank you so much. Okay. Well, the good news is that is pin 1 fully inserted? Let's give pin 1 a tug. Yeah, pin 1 is fully inserted. Okay, so the rest of the pins on upper limit look good. Upper limit is X35, by the way. Okay, let's check. We're gonna do stage motors next. Stage motors does not appear to have any bullshit jumper going on. Okay. Come on. Okay, stage motor looks good. All the pins are in. There's no weird double jumper connectors or anything, so not nearly I was worried. Yeah, this double jumper, there's two wires and one connector thing. Not liking it. Okay, I'm looking at upper limit now. Okay. Pin 1 seems like it might not be fully seated. I'm not sure. It's good. Pin 1 is good. Okay, cool. Yeah, I covered one eye up when I was like looking at it. I was like, oh, I can't tell if the pins are in or out now. I completely lost depth perception. That's funny. So pin 13 is slightly suspicious on this one. Here, we're gonna pull on it slightly, because if I pull on it very slightly and it breaks, that's a problem. Oh no, this one's better. I think they actually managed to catch the insulation in the strain relief on that one. Okay, so those two look good. Okay, let's go up to middle limit, which is in the top right corner here. Okay, bottom row looks good, top row. Okay. This has got that doubled up thing again. But it's looking okay. We'll give it a slight tug just to test it. Yeah, okay, top row, that one's good. Okay, let's check our power connector now. Okay, power connector pins all look good. Okay. I didn't check that fuse earlier. And it feels good. I mean, the ground's attached. I don't know what else you can really ask for. Attached via 1/4 inch quick disconnect. I mean, you can ask for more than that, but given that that's what it is, don't know what more you can really ask for. Okay. Okay, I'm gonna get some tools so we can pull that connector out. Well, I will say when you guys like tag me, it does it highlights it for me. I don't know if it highlights it for y'all if the tags are working or not. Okay, tools. Time to get the connector out. Should just be one tool pretty much. Just to get those standoffs out. But we'll be prepared with that too, just in case we need it. Good old plier wrench. Okay. That is not the right one. Might not have the right one for these. But I do have wrenches, so it'll be fine. That's looking pretty small. Yeah, that's too small. Okay, well, I got the wrench, so that'll work. I'll get you right in there so you can see what happened. So there's that white and black wire that's bad. So that's that right there. That's the wire that broke off. So that whole connector is going to come out. That's the broken wire. But hey, I'm glad it broke on me, not somebody else, right? That's the point of MRO, Maintenance Refurb Overhaul. Love MRO. Love using a standoff as the connector. The whole, and we haven't even like talked about the whole no back shell thing yet, right? Like, there should, come on, no back shell, really? I mean, they do the same thing on Sigma. After I get this out, I'll swing, or I'll point the camera at Sigma's basically identical stage controller. Sure we don't lose the washer. Or I guess the lock washer. So the bottom pin on this is going to be slightly more interesting. Did we lose the camera? We did. What got unplugged? I see what got unplugged. Okay, we back? Looks like we're back. But we're back in manual mode, so it's too dark. I forgot to leave the comments up on screen where I could read them from here. So put whatever you all want in there, and I'll have a good time reading them when I get back. Hopefully you aren't telling me that I'm missing something. Okay, I've got my eyes on everything that's on this, and there's only one washer, right? The other is just the ground? Yeah, okay, we're good. Okay, so we've managed to not, to my knowledge, drop anything into the board. Okay. So, yeah, that's our broken wire right there. Went right in like that right there. So what my plan is, and again, I'm looking for feedback here, is I'm gonna cut, I think I'm gonna cut this loop here. Yeah, I need to cut it because I need to heat shrink. So I'm gonna cut this loop and then just splice the, what will end up being the 3 wires together. And I think that's how we're gonna get that reconnected. Because I don't want to try and redo what they did, because that's not, it's just going to have the same issue. So let's see if I can get this whole cable out entirely. Because if I can just work on this outside the microscope instead of working on it inside the microscope. I should be able to get this out, I think. Okay. So I have to take off this bulkhead connection right there. So what do I want to do? Do I want to take off that bulkhead fitting? Or bulkhead fitting. Do I want to take off that bulkhead connector, or do I want to just work on soldering this down here? I think I almost want to just work on soldering this down here. This shouldn't be that hard to do down here. What do y'all think? What do y'all think? Okay. I can't use an extractor tool because it's full. There's no room for the extractor tool. There's absolutely no room for the extractor tool. The MCUs they use don't even have DSP. That's amazing. Yeah, that is a crimp. These are all. These are all crimp. I can see like the crimps. Or all the connections that went onto the PCB are all crimp. Man. So I have a good. I have a really big stock of dried up conductive silver paint, but I can put solvent back in it. Yeah, both sides of the loop are double looped, right? It's well, I mean, I guess to say that broke isn't, but I don't want to mess with that side that's in the connector. I do have an extractor tool. It's already, but like the crimp is already huge in there too, so I don't think I can get the extractor tool past the crimp because the crimp had both wires in it, and there's like, so the strain relief is like really fat in there. It's like touching both walls, so there's like not room to get the removal tool past the strain relief either. It's just ugly in there. It's just really ugly. I don't like it. But so I did think about like removing just an insulation and wrapping it around, but then how do I get heat shrink on it? I didn't think I could get heat shrink. Well, unless I like just remove some insulation and then fold it and then cover it that way. But yeah, it's gonna be kind of ugly anyway, like no matter what I do, I think. So because I want to do heat shrink, I think it's easier just to cut the loop in half and make the splice with all 3 wires right there. But unless you can come up with this. Yeah, expensive hermetic D-subs on one side, and then like these terrible crimp connections where they've shoved multiple wires into like one pin on the other. Like it makes complete sense, right? Like, I mean, somehow it does make complete sense. It doesn't make sense, but it makes sense, you know. But yeah, stuff like this is just kind of par for the course, it seems like. So I think cut it and splice. It's my best option still. I'm gonna start getting soldering tools up here, and if y'all come up with anything better, you know, let me know. Yeah. Okay, let's get. I'm gonna start getting soldering tools out. They should all be in this bag right here. Okay, there's the solder. That's not the right size heat shrink. Okay, there's the correct size heat shrink in that bag. There's some other tools I probably won't need. There's the power supply. I mean, I could go get like the fancier soldering equipment off of the bench. But I'd have to, that'd be a lot of work. So we're just gonna do TS80. And TS80 is great. Oh no, the button on the TS80 is broken off. Okay. It'll probably pop right back in, right? I bet the button's in this bag. Is the button in this bag? See, we're missing something we're gonna need to press. I mean, there's still, I guess it's just, I can still press it. I just gotta find something to poke it with. I think the button's here. It's just buried in a corner. At least that's the story I'm gonna tell myself. Did it somehow end up in the bag with all of the pins? Because I'm not seeing the button. Is there a button there? Any of y'all see a button in there? There's a flashlight. That's gonna help. Okay, no button. Not that I can see at least. Maybe it's, I'll just check those edges real quick. Okay, no button. We'll just poke it with something. And then we're gonna need power over here. So I need to get an extension cord. Yeah. We're not rebuilding the whole connector. That's, we're not, I don't, no. No, no. We're not going, we're not going that far tonight. Okay. I came back here for, oh, I could actually bring the fume extractor card out pretty easy, I think. Oh, no, it's a cluster. It's a whole cluster. Soldering one pin. Extension cord. Okay, we got an extension cord. This will be useful for the heat gun for later too. Okay, extension cord it is. Plugged in. Okay, let's start cutting some wires, I think. Let me, oh, well, if I want to cut wires, I need the flush cutters. I'm probably going to end up using flush cutters to strip the wires too, but we'll grab the wire strippers. I just don't know if I have enough length there to actually like get the wire strippers to grab on. I'll grab some tweezers too. I don't know what I need them for exactly right now, but they feel like they might be useful. We'll think a little bit ahead, and we'll grab the alcohol bottle now too, so that we can clean up our work afterwards. We'll grab a microfiber to aid with said cleanup. Okay, we got things to cut. I want the flat pliers and the round pliers. You know, I'll grab the forceps too. Why not? Why not? Hello, everyone. For those of you just joining us, we discovered this connector here. We got this jumper. It goes black wire from pin 15 to pin 14, and there's two wires crimped into pin 14, and then one comes up and they go to pin 13 here. That white and black wire there, I gently poked it, just ever so slightly poked it, and it just popped off. So we're fixing that right now. It's gonna be a great time. We're gonna do this while down there, surrounded by light boxes inside the microscope. It's gonna be great. So I just pulled that connector out. That's the connector that you see pulled out kind of in the top middle of the frame-ish. And yeah, we're gonna be effecting repairs. So yeah, let's do it. Teeth make a great tool for stripping short wires like this. I don't believe you. I mean, I'm sure you're not wrong. I'm just not doing that tonight. I like my teeth. Okay. So the plan is, let's take as close of a look as we can on these. So the other jumper set, yeah, it's surviving the pull test. Oh! Okay. Okay, cool. God damn it. Ugh. That simultaneously makes this easier and also much worse. Piece of... Yeah, they didn't... even see where the broken strands? Yeah, I do see where the broken strands are. Okay, so the strain relief never clamped onto the white and black wire at all is what I'm seeing. But I don't, why, it's not even like a good crimp pin. It's a shitty one. Or I mean, it's probably a good one. It's not, well, it's folded. It's stamped and folded. It's not machined. Machine contacts for the win, by the way. I might feel differently about machine contacts someday if I'm buying like 1,000 of them at once, because they are kind of expensive. But why did that just come out? Yeah, lol indeed, right? Like I was like, oh, I can't get the pin out. I can't fit an extractor tool in it. It turns out you don't need to. It's just gonna come out. So, okay, so that changes our calculus on this a little bit. We'll do we won't cut the wire on this one, it's not intentionally. And then we're gonna do a splice kind of like that, a little bit high up, and then we'll be able to bring a piece of heat shrink up onto it. So that should work out pretty well. Love the Knipex 1252 195 wire strippers. Absolutely my favorite wire strippers. The adjustment mechanism on them is excellent. They do a really good job. They don't work on like Romex or building wire. That's the one they don't do, but they do everything else great. Okay, how much do we want? Let's do like 4 or 5 millimeters. We might go a little bit longer, but I don't have a lot of wire lengths to work with here. So we're gonna kind of high up on it. From like there, so we're gonna start. Okay, here's where we're gonna do some precision flush cutting. I think that's where we wanna be. Measure twice, cut once, right? Yeah, that was like a pretty good spot. If I want to, if I want to strip off a little bit more, I can. Which I probably am gonna strip off a little bit more of this one too. Looking at it now. But we'll go just a smidge further back. Yeah, it's like a millimeter further back. Okay, so now precision flush cutting. One of the tricks to precision flush cutting like this, precision stripping, is you just kind of keep going around it a few times, and you very gently squeeze each time. So you get through the insulation, a little bit slower, but because you're applying so little force, you're a lot less likely to accidentally go through the copper. Yeah, that should be an adequate amount to peel off. Some precision stripping going on here. Yeah, this could turn into a very different type of live stream. I'm not gonna go there though. probably wouldn't be able to get away with doubling those pins up if they use black shrink strain relief. Yeah, probably. Yeah, that's not a bad method at all, yo mama. This wire seems really brittle, and I'm trying to avoid bending it very sharply. We're getting pretty close, though. Okay, I can see the conductors. These are like not. These flush cutters aren't in great shape. I had better ones. Okay, we're starting to get somewhere. Hey, I knew the tweezers would come in handy for something. Make sure I'm not grabbing any strands. I don't appear to be. Nope, watch the tweezers there. But I got the insulation right where I want it. There we go. There we go. I'm going to lengthen this a little bit. Okay. There we go. So yeah, we are going to lengthen the amount that this one strips so we can wrap that around a little bit. Yeah, trained hamster. That's the way to do this. Trained hamster is absolutely the way to do this. Yeah, I love it when it just leaves the insulation on perfectly like that. I'm gonna chamfer the insulation so that the wires get right next to each other. Now, got a little piece of plastic in there. I don't want to get any FOD on my solder. Oh yeah, look at that wrap. That's a good one. I am pretty happy with that. Check that out. Manual focus, please. That's looking pretty good. I love these flat, shiny pliers for this because I can grab this and just kind of like roll it around like that. And that's how I get those really nice wraps like that. So that's right where we want it. So I'm gonna get the solder on that now. And then we'll get that heat shrinked up. Yeah, doesn't that look good? I think that looks good. I think that looks real good. Cool. This is what makes it all worth it. It's all about those sexy mid-span splices. Okay, I already got the soldering iron out. It's right here. And remember, cleanliness in your soldering joint is next to godliness. And I'm joking. What it actually is NASA says make your solder joints clean. So we're gonna wipe this one down first because we were handling it quite a bit. Inspect for any FOD. I don't see any. The end of that wrap is poking out just a smidge, so we'll get that flattened out. There we go. Okay, let's get our iron plugged in. And we'll get this heating. Boop. There we go. I don't need more solder, I need more flux. Almost happy with that. There we go. That's what we want to see. That looks great. So I could have maybe gone a little bit closer to the crimp, and that might help with the heat shrink on this angle right here. But I'm looking at how far my heat affected zone on the insulation is, and I got about as close as I would want to with the heat affected zone to that crimp. So I'm pretty happy with where I did this place. Yeah, you think about plastic cold flowing under a crimp. When you heat it up, it does a lot more than cold flow. So this is a TS80, not a TS101. So there's our splice. Manual focus, please. I think that looks pretty good. Yeah, look at that. Cool, okay. Let's get heat shrink on it. Let's get the heat gun out, and let's get this thing back together. Is that thick enough for that? Probably not. We might, that's too thin. Okay, we'll go one size up. So yeah, they got this size in black. That's a pretty good size. I got slightly larger. I think it's slightly larger. Yeah, it is slightly larger and clear. It's a little bit large. Okay, we probably want to use the black. Actually, I have a different bag of heat shrink I can grab. Let me do that. And I also need to get up to get the heat gun anyways. So, okay, heat gun and heat shrink. And we got the cutters for the heat shrink already. Okay. Huh. I've used the heat gun on stream. What did I do with it after using it? And ultimately, if I can't find the heat gun, I'm just gonna go get the hot air station. It'll take a second, but it's not that bad. I just wanna know what I did with the heat gun. Because I had it plugged in on there when I was using it on stream. Because we were putting heat shrink on the stuff in the emo box. Oh, it is right here. Okay, cool. Okay, heat gun procured. So we want heat gun and more heat shrink. Actually, I'm gonna go to the place where all the heat shrink comes from, I think. Well, at least in my shop. What have I got? Anything I like for this? I mean, I want to use clear. I like clear heat shrink, but we'll use black if we have to. Okay, we got heat shrink, we got a heat gun. Oh, what did you get stuck in the filter? Okay. So let's figure out what heat shrink we're gonna use. Have I got any clear of exactly the diameter I want in here? Does not appear that I do. Okay. Oh, I do have some. There we go. I think that's what I want. Yeah, there we go. That's exactly what we want. Okay, how long do we want it? That's the next question, right? Probably that long. And I'm just gonna slightly expand the end that's gonna end up going over both wires just to make sure I can get it as far over as I want. I love these pliers for expanding the heat shrink. They, it reminds me of the like Uponor style PEX. Okay, I think that's what we want. I think we're gonna wait to shrink it down until I've actually got it in. I might need to split it open a little bit more too. But yeah, I think we're gonna put that pin in now. Hey, it actually locked in this time. Okay, cool. I think I'm gonna snip that end open a little bit. I don't quite like how it's pulling on everything. Okay, I'm more happy with that bend radius. There we go. Okay, cool. Let's get that shrunk. Okay, there we go. That's the repair. Check that out. Cool. Okay. So, time to get that reinstalled, but first, I got a little bit of a mess going on here. It's amazing how that happens so quickly. Check this out. All that for one silly little wire that broke? Isn't that fun? Okay, cool. I don't know what you got stuck in the filter, because I can't actually see anything stuck in the filter on my end, so. That's funny. Okay. I'm gonna clean up a little bit here, just because I think that's the only repair we had to do in this thing. Actually, yeah. Okay, that's the solder. That's the soldering iron. The power supply for the soldering iron. Very important that I remember that I have a contact burnisher in my soldering bag. Is my switch in here? No. Is my switch in here? No, it's not. Okay, that's what I'm going to clean up for now. Wash my hands up. Okay. So now we just gotta get this plugged back in, get the ground fixed, and we should be done with the stage controller if I'm not mistaken, right? Oh, my cursor disappeared again. God damn it. Why does it do this? I don't get why it does this. Or not my cursor, well, like, the cursor can, my mouse is there, but if I try to type something, it's not there. That's always weird. Okay, what do we got left? So that's the pin 13 fix. We can check that off. Why won't it check? Oh yeah, I love the Weir screwdriver set. That thing's awesome. Okay, my computer is freaking out. It's like, I can't edit. It's back now. Why is my cursor gone? Okay, that's fine. There we go. We got one checkbox done. Love that for us. So good. So good. So good. Probably installed on a Friday at 4:52. I'm going to say 4:58 actually. Okay. Well, I haven't finished the repair yet. I'm going to uncheck it because I have to reinstall the connector. And who knows what's going to go wrong before I reinstall the connector. So I'm going to preemptively uncheck that before I like tempt fate. So, okay, let's get this connector reinstalled. Okay. This is going to be interesting. I'm going to flip over to camera mode real quick. Well, flip over to photo mode. God damn it. There we go. It's not going to show you guys the photo on screen because I'm not over there to click the button, but it will save it so I have it. There we go. Cool. Okay. I need to get the OBS app set up on my iPad so I can like control the stream from over here instead of having to get up every time to touch anything. Okay, are we back? I think we're back. There we go, we're back. Yeah, exactly. No, that's exactly why I unchecked it. Check the other connector with a double loop. I mean, I was looking at it pretty closely. I could pull it out. It's probably not a terrible idea to pull it out. Let's get this one reinstalled first, though. Okay, it's fully seated. Now for the awful part. And this is admittedly just awful because I don't have the right tool for it. Okay, that's tightened down. That's good. Tear bubble. Tear bubbly. It's not a tear bubbly idea. Okay. The boot OK fiber. Don't we love the boot OK fiber? Okay, not dropping the washer. Click. Okay, that one's done. So I did get a nice and close look at this other one, but pulling it out's probably not the worst idea. We're here, so might as well do it, right? I do have a lot of sizes of Wera socket drivers. I don't have this one in particular, so. Okay. Don't drop the washer. Can't even get my hands on that one. Oh, this one's weird because it's got the, this is one that's holding down the ground. Okay, got the standoffs out. Let's get the connector out. Okay, there's our connector. Well, everything is passing the tug test, which is good. Okay, so the difference here is that on this one, it's kind of hard to see on camera, but you can just, so the other one, where's those tweezers? Oh, I moved the tweezers, okay. Something sharp to point with. So on this one, so this is the black wire that goes in, the black wire, and in this case the white wire with red dot is what goes into pin 13. I can just see the conductors on the black wire there. So the insulation of the black wire is not clamped by the strain relief on this one. In this case, the white wire with the red dots is clamped by the strain relief on this one. So that's the opposite of how it was on the one that broke. On the one that broke, the black wire was clamped by the strain relief, and on that one, what was a white wire black spot was not clamped by the strain relief. So this is likely more resistant to the failure. So that's good. Let's just poke on those pins, see if they happen to want to pop out. But we did give it the tug test, so I'm being very careful to only push straight down in this so that we don't end up bending a pin. Okay, so all the pins that we would be suspect of being loose are not, so that's great. So we're going to go ahead and reinstall that one. We're also going to move this wire around a little bit. The white one, white red spot. Actually, we're gonna snip the strain relief just a little tiny bit, because that's going to let us get the wire just slightly closer to where we actually want it. Well, maybe we'll just move it this way. Yeah, we'll just reach down there and move it now. Okay, that's taken a lot of strain off that, so. Cool. Okay, let's get the standoffs back in. Security socket, that is cursed, and you need to take that back and don't tell BMW about it. It's almost like, yeah, it's almost like a remote joystick. There is a joystick port on another one of the boxes that we're going to get to, actually. Whether or not we're going to get to that tonight, I don't know. Okay. Okay, now we just got the hardest one to put back in, and then it'll be good. And this last connector that's here doesn't have any of the double ones. Well, there's one in the top right corner that has the double ones, but it was much further away from everything, and I was able to get pretty good look at all that, so not nearly as worried about that one. There's a real nice shot of what we're doing. That I immediately block with my hand. There we go. Okay, we're getting close. Just gotta very gently maneuver all these wires. Okay, it's as tight as I can get it with that one. So now we come at it with this one. Click. Okay. Are we happy with this one up here? I'm pretty sure we are. Where flashlights go? Did I move them all somewhere? One of them's up there. There's the other one. Okay, cool. Just give that jumper a tug test. Yeah, we're looking good. Oh, that ground's loose. See that? Love loose grounds. God damn it. Okay. Just doesn't end, does it? It ends someday for all of us. You had autofocus was off. Why did it change the focus? Click. Check the other side. Side's good. Well, I will say, I would much rather be doing the work that we're doing right now than the work I was doing to the email box. Much, much rather be doing this than email box. Click. That one wasn't bad. It's probably loose enough to spin though. That one, the bottom one was tight. Why wasn't the one that had the ground on it tight? Come on. Click. Yep, that's tight. Cool. Okay, let's get the this ground right here taken care of. So let's take off the one that's in the way of getting the one that we actually want to get tight. Click. Okay, let's put this one back on, get it tight too. Somebody can check off what we completed, by the way. If any of you all get satisfaction from checking boxes off. Yeah, the transistors all have those little like plastic spacers on them. I thought that was kind of cool. Let's see here. Yeah, the clear wire, it's a Litz wire ground, I think. Litz wire is a really, really high strand count ground. It's good for very low impedance for high frequency signals, which is what you want when you're dealing with high voltage systems like this. It is, and then on both sides it's connected to kind of terrible ground wire. So it's like, why did you bother? Like, why did you even bother? It's just a waste. It did not matter that they used Litz wire just because of what they did on the other two sides. Have I found any grounds that aren't loose? Yeah, some. Not inside this. Well, this one here wasn't loose on this one. Okay, and now the outside's also properly grounded. Cool. So we can check off the pin 13 repair, and we can check off that we got everything grounded. Make sure that's fully seated, which it feels like it is. Let's make sure all of our little 3-pin ones are fully seated. Let's pop this one out. I don't know what that is. We're going to pop it out. We're going to check the torque on it. Because we've had issues with wires not being torqued right. So we're going to check this one too. Screwdriver bit for that is in my hand. The fine strand, it's the high surface area. And yeah, and each conductor being individually insulated so that you get maximum ability of the wire to carry current via skin effect. Okay, this one felt pretty good. Yeah, that was fine. That was properly torqued. Love to see it. Oh, there's all the grounds on the, there's more grounds to check. There's all these grounds on here. Do I have the one? I do not have. Well, is that the one? Is that the one? It's not the one. Okay, let's check on these little buds. We're going to check these ones based on if they turn or not. That one doesn't. That one doesn't. That one sure doesn't. That one doesn't. That one doesn't. And that one doesn't. Okay, well, all of the ones on these D-subs here are much better shape than... Oh, there's one more. There's one on the power one. And that one doesn't. Cool. All these ones on the D-subs here are in much, much better shape than on the rest of what we were dealing with here. So that's great. Yeah, welcome to the channel, Curious Scientist. Yeah, it's individually insured wire. Just, do you know how many insurance policies are taken out on that one ground wire? So yeah, Curious Scientist, we're going to be doing SEM repair. We're going to be doing SEM brain up. We're going to be doing imaging. So yeah, we'll be doing a lot of different SEM. We'll even do TEM. We'll do TEM. We'll do FIB. We'll do dual beam at some point, I'm sure. Okay. I think we did it, chat. I think, well, okay. Let me just make sure all those 3 pin connectors that are all over the board for all the weird little add-ons they decided that they needed later. Let me make sure all those are properly seated. Let's make sure these fibers are tight. I still love the boot okay fiber. That's really funny to me. Oh, this fiber is loose. It's very... Is it even in all the way? That was so loose. God damn it. Of course it was loose. Yeah, it feels like it's seated all the way. Okay, let's actually tighten it down now. God, whoever swapped this board in this box last, I have thoughts. I mean, you know what? This was in a fab. It ran, and they probably got it done really quickly, which is probably what the customer wanted. That's why I like to get a lot, like just knock out a lot of really thorough maintenance before we actually like kind of hand a tool over. Because then I get to do all this stuff to make it really nice, and that's great. Okay. I think we did it, chat. I think we're on to the clean out part. Clean all that dust out. Okay. Oh, and I gotta turn that camera back on. There we go. Oh, man. Feels good to be standing up after that. Feels real great to be standing up after that. I'll post the link to the notes, so something that you might enjoy for those of you just joining us is you can edit the notes that are on stream. Oh, a JIV? A JIV. You spent time on a JIV. What did you think of a JIV? Oh, man. A JIV. So JIV is Japanese ion beam, as opposed to JEM, which is Japanese electron microscope. I don't even think Joel USA knows how to service JIVs necessarily. They're learning again. They're figuring it out. Okay, what do we got left? We got internal inspection photos. I want to take one picture of the. I want to take a picture of the Leo. No, of the Leo like logo on the board because I think it's really funny that there's still a Leo logo. So brief corporate history. God, I don't even know how Leo ended up with the Zeiss IP. So there was like the Zeiss like DSM digital scanning microscopes, the like, what was it, like 900 series, you know. I think they even had like the DSM, like I think it was like what, the DSM 980, and they even had like a field emission DSM back in the day that was like kind of the predecessor to the Gemini column. Somehow, some way, something happened. Oh, and then there was the Cambridge, and there was the Cambridge instruments too, right? I don't know how like Cambridge and Zeiss ended up. Like the Zeiss microscopy, or Zeiss electron microscopy division, I think Cambridge must have purchased them or something, or Cambridge and Zeiss got purchased by somebody. I'm pretty sure those two merged. And that's basically how you ended up with Leo. I'm a little bit fuzzy on the history here. But so you had Leo in the UK. So Leo had all the IP for all these microscopes. And then it all actually ended up going back to Zeiss at some point. So this is a Zeiss Merlin. It says Zeiss everywhere on it. I found Leo in one spot on this microscope. And that is on that board in the top left corner there. So we're going to get a picture of that one Leo logo because that's funny to me. Then we're going to check out the temperature safety on the heatsink. the water-cooled heatsink on this unit because we want to make sure that this thing knows if it's overheating because it's bad. We don't want things to overheat. And then yeah. So I'm very curious about your experience on the Jib 4700F. What 4700F? Huh? That's a hell of a model name. Is that a dual beam? What is that? Because the 4700, that is their dual beam, isn't it? Yeah, that's their dual beam. God, what column did they use? It's because I got a 67. Because that is the hyperconical gentle beam. Yeah, Joel has like given up and restarted ion column development. Like I feel like 3 times at this point, kind of. Okay, cool. So we got some stuff done. We got some stuff done. We did a thing. We checked off 2 boxes. We've been streaming for 3.5 hours, and we got. I guess we got 4 boxes checked off. Okay, let's get that last photo real quick of that Leo logo because I think the Leo logo is funny. And then we will check the thermal safety. You know what we're gonna check the thermal safety first, and then we're gonna get a picture of the Leo logo. Yeah, let's check the thermal safety first. Cool. Oh, it had the gas injector options, nice. What type of work did you do on it? Like circuit edit or biology or what kind of stuff did you get into? Lamella prep? Did it have a lift out on it, like an Omni probe, or I don't know if Joel had their own Omni probe or not. Okay, so I gotta get down. The thermal safety is, you can just barely see the head of the screw right there. So that right there is the temperature sensor. That's the thermal safety. So we're going to get real close to that. The lens on the camera is too big and I don't have a probe lens for it, so. Okay. I get it now. Okay, the Leica part is what I was missing. Thank you for posting the history. I really appreciate that. So cameras got purchased by Leica. Leica and Zeiss worked together in the Leo cooperation. Okay. There was that service engineer who's also an actor who told me all about this at one point. It's all coming back. Okay. Steel industry. Nice. Why did the camera battery died. Let me put a new battery in the camera. Focus, please. Please focus. Right? Thank you. Okay. Let me get this battery back on the charger. So a lot of imaging, EDS, WDS, EBSD, TEM lamella. TEM lamella can be quite cumbersome. Was there good automation on the Jib 4700F for TEM lamella prep, or were you kind of just doing it on your own? Okay, let's get all the way down in here and check on this thermal safety. So what are we looking for? Well, it's got those two little blue wires coming off of it that you can't really see. I'm going to make sure those are soldered in well. Going to make sure nothing looks strained. Want to make sure it's tight, it's in contact, nothing's shorting. Okay, solder looks great. Okay, it's certainly in contact. And can I twist the little crimp that it's in? Nope, okay, it looks like it's mounted on there pretty well. Cool. So thermal safety is in place. Well, I guess it's really a temperature sensor. Calling a temperature sensor or thermal safety because it's gonna it's gonna rely on that FPGA to be safe. So and the analog readout circuitry, and so that there's, you know, I don't think it's a thermal switch. I think it's I bet it's a PT100 because I know Zeiss likes to use PT100s. So yeah. Something was was it with the ion optics that was something was off? Because like I know that Joel USA knows how to. I don't know if you had Joel USA servicing or not, but I know Joel USA knows how to service the electron columns really well. They're figuring out the ion columns, you know. Okay, so we can check off that we've done the temperature safety. Okay, let's get that picture of the Leo logo because I think the Leo logo is funny, and then let's clean it out. So that's gonna be vacuuming it out because there's a bit of dust in it, which I should have just done at the start because I've been working in the dust the whole time. So this microscope came from a clean room, so it was pretty decent. Like for how many years this microscope ran, it's doing great in terms of the amount of dust that's in it. Okay, cool. So we'll get the camera flipped over to photo capture mode. And we'll also grab a picture of our repaired connector installed because we spent a lot of time on that. But that was a good find. I'm really glad that I found that. Okay, so I got to unplug the camera. Once it figures out it's on UVC mode, choose USB connection app, photo import remote control, set, plug it back in. Mac OS is going to index things, and then it should show up on screen. There we go. Cool. Let's bring this light down so we can illuminate that Leo logo better. Autofocus on. More depth of field, more aperture. Well, smaller aperture, more aperture disc, more aperture blade. Okay, that's a picture of our Leo stuff. Let me just grab a picture of our repair. And that's going to be it for the photos, I think. So for those of you just joining us, the thing that I'm photographing right now is a repair that we made to this where one of these wires It just popped off when I touched it. And so we spliced it back together. And I'm pretty happy with how that repair went. So snap some pictures of the other connectors that we messed with, just so we have a picture of what it looks like after we've touched them. Some shots from further back. Okay. There we go. Okay. Check off that stuff now. Moving atoms around. Yeah, that's what lamella prep is. You're just moving atoms. Don't suck out any jumpers, I know. The electron optics issues. Interesting. Too bad that the photos provide worse depth of field. Yeah, I mean, it's depth of field is actually pretty good. I'm getting with this camera. I mean, I'm in focus from one end of this photo all the way to the other, and that's because I'm shooting at f10 right now. And the reason I can shoot at f10 is because this camera has an insane high ISO performance. So 6400 ISO, no problem whatsoever. And I think there's actually a depth of field preview thing. Yeah, tethered shooting's cool. Live view focus meter. Oh, look at that! Look at that! I got a bar that shows me how focused I am now. Isn't that cool? That's cool. Isn't that fun? Focus assist. I like that. I'll leave that on for y'all. I'm sure y'all like to see when I'm in focus and not. Yeah, too bad photons provide worse depth of field. Yeah, ain't that the truth. Okay, so let's check off some boxes now. Internal inspection of photos, done. Okay, so we just got to vacuum this thing up, clean it up, and then we close out of this box and on to the next. Cool. So we're going to go back to that mode, and then I'm going to flip the camera back to video. I guess I just don't have any battery left in these. Let's get this plugged in for my own sanity. Okay, let's see here. We want a vacuum. I think the vacuum's over there. Come on, there we go. This thing feels pretty heavy. I need to empty it out. And I thought I had. Yeah, okay, we'll be good. We'll be fine. Oh, did I unplug that camera? Is that camera still going? That camera's still going. Okay, we're doing great. We're doing great. And then let me put the comments up where I can see them when I'm over there. Okay, let's put the long nozzle's not in here, is it? The long nozzle's not in here. Where's the long nozzle? Where's the long nozzle? It's on this cart, isn't it? It's maybe on this cart. It's maybe not on this cart. Okay, it's looking less likely that's on this cart. Huh. Where'd the long nozzle go? Well, we'll be fine without it. This one's a pretty relatively small nozzle. Check that out. It's looking pretty good. Cool. Okay, we can check that off. Are your cats fans of vacuum cleaners or not? I'm gonna guess I know the answer. My cat surprisingly doesn't care. It's kind of great. Okay. Just check over everything one more time because we did just vacuum in here. Those are all in. I don't think I vacuumed any jumpers up, so that's good. I'm just gonna, you know what? I never popped the maintenance lock out. I'm gonna do that real quick. So I can peek at the pins. We did look at the back of these pins already, but I want to look at the front of them too. Okay, those all looked good. Let's get that back in. Okay, both sides clicked in. Verify there's no gap. Oh, there's a gap on the right side. Is that not fully seated? There we go. Okay, everybody, wave goodbye to the stage controller. Oh, actually, you know what? Before I do that, before we close that up, I did promise that I was going to open up Sigma here. So this is Merlin that we're looking at right now. And for those of you who are new to the channel, there's more than one FEG SEM in this room. So that's Merlin. That's what's under rebuild right now. This right here is Sigma. That's another Zeiss 20. I think this is a 2011. Yeah, so that one is actually running right now. Well, I vented it right before the stream because I didn't want to listen to the vacuum pump while we were streaming. So, and then there's a whole bunch more microscopes in this building. That cable's not long enough to reach, is it? So that's the rest of the shop back there. Earlier streams we put up all of this tubing, and then back there's 4 more Joule thermionic 3 more Joule thermionic SEMs, 2 Joule field emission SEMs, 1 Joule thermionic TEM, another Sigma. And yeah, I think that's it right now. So we got a lot of electron microscopes in the building. Oh, and then I was going to show you inside Sigma real quick. So put a picture of that board in your head, okay? So that's Merlin's vacuum controller, and we're going to go look at Sigma's vacuum controller now, or not vacuum. Sorry, stage controller, not vacuum controller. So that's Sigma's vacuum controller right there. So Sigma's built very differently than Merlin. First off, it doesn't have nearly as nice a vibration isolation. It's got a stage I'm not a huge fan of in it. So that up there is our stage board. Isn't that fun how buried it kind of is? I mean, if I swing the door open, it's not as bad. But do I have autofocus off or something? No, I don't. Okay. So that's basically the same stage board we've been looking at. So on this one, you can see there's the FPGA underneath. Monochroma, if you want to read that real quick. There you go, that's the FPGA. And yeah, oh look, there's back shells on the connectors on this one. And they're not even using half the limit switches. Isn't that great, there's back shells? Who would have thought that back shells would ever be so useful? Yeah. So yeah, same vacuum board on Sigma. I think that's the only board that's the same. Okay, how badly do you want to know what they use on the vac board or on the stage board? And then here's another comparison. Those are the they're using the which ones are these? The IP100 power supplies is what we're using on Sigma for the ion pump controllers. Okay, autofocus, we're going the other way. There you go. So yeah, different ion pump controller, same manufacturer. And then that's the Sigma vacuum board. And it's a little bit of a cluster. There's a lot going on. There's a lot of like daughter boards and other stuff. It also, it's been relatively stable over the years, and it does a good job. So, you know, it just has a lot going on it. It has a lot going on it. But it does a pretty good job. I've had issues with the fuse holders in these ones. Oh, these are different fuse holders. Okay, so hopefully we'll have less issues with the fuse holders on Merlin compared to Sigma's fuse holders. So, yeah. So that's comparing it to Sigma. And then the heat sinks are kind of similar. I've always thought Zeiss has done a good job at the heat sinks, especially compared to, I think the worst I've seen, I'm not sure if it's the worst. Most problematic have been some Joule heat sinks for a variety of reasons. You're correct that I can pull that daughter board. I just don't want to pull that daughter board. So I haven't, because I haven't wanted to. And there's only an FPGA underneath it, and I don't think I would find anything looking at the FPGA. And the insertion force on those on that number of pins is very high, and I don't want to deal with that. So yeah, it's nice having multiple scopes of same manufacturer nearby. Probably should check under that PCB. Like there are reasons to check under that PCB. There is literally just the FPGA, and I am concerned about damaging things, just because of how much force is required to get that board on and off. So. Well, wow, we got a lot of views tonight. This might be the first live stream where we've had 100 views like during the live stream, so that's cool. You want to compare and contrast? I know. I mean, I understand wanting to. I don't do no harm type thing, you know? Like, I want to be careful. And so it's like, what's the risk? What's the reward? Knowing what FPGA is kind of cool, but I don't. If I thought I might find something like that would be of concern, I absolutely would pull it. I don't think that the risk reward ratio is there for that. Okay, so we've done everything on it. I kicked a screwdriver bit. There it is. Okay, so we'll close out. That's our last item on the list. Okay, cool. Let's close it out. Okay, are you happy with everything still? This one zip tie has been bugging me, so I'm going to cut off that corner. Clean that one up. I don't want to reach around for that one, but that one's sharp too. Okay. Well, I'm glad we're not using the boot okay fiber because there's a little nick in it. That's kind of funny. It's pretty out of the way of where we were working, so I don't think we did that. Cool. Everybody wave goodbye. Bye, stage controller. Okay, not quite yet. We're gonna wipe down the inside of this panel first. Those of you wondering, that is straight 95% ethanol. My favorite cleaner for electron microscope usage. Well, okay, it's not necessarily my favorite, but if I'm going to be just wiping something, it's my favorite because it doesn't leave a residue. And it's not isopropanol, it is ethanol. And it is 95% ethanol. Or at least it was when I bought it. Who knows what it is now? It's not anhydrous. And this is going to spike the VOC meters in my shop. I think it's fun. Like, it's like you drink this stuff, and the VOC meters are like, this is unhealthy. And I'm like, well, the VOC meters might be right. But I think in this case, this VOC is less bad than other VOCs they pick up. But this will, like, across my entire 2,000 square foot building, like this amount of ethanol will spike every single meter I've got above 5,000. So that's funny, I think. Well, I mean, okay, if you want to, we do want to know what chips this microscope uses. I'm curious too, and I'm curious what you would be able to share about it. But you know what? It's the same FPGA that's on. I almost guarantee it's the same FPGA that's on Sigma. So we're just gonna go with that. Bye. Oh, interesting. This cover is it matters what orientation it's in. I wonder how that happened. Come on, line up, please. Okay, last screw to get started. Okay, they're all started. Click. 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 Ta-da! Okay. I do use it in the chamber actually. For microscopes that are already particularly dirty, and I was like, okay, there's diffusion pump oil in this chamber. They do not want to take the amount of time it would take to completely clean the diffusion pump oil out of the chamber, so we're going to use a lot of ethanol, and yeah. But yeah, if you got ethanol in a sample and you let that go in the chamber, it'll splatter everywhere. Yeah. If you think ethanol going in the chamber is bad, I've seen seawater. I've seen stuff from the ocean that's still wet put directly into an SEM. So I'll take ethanol splatter any day over seawater. Thank you, Friday Harbor Labs. That's a spicy microscope there. Okay, stage controller is done. There's so many left on the list. Look at this list. We got a ways to go. Okay. We're 4 hours into this stream. What do we want to do here? I mean, we are at a natural stopping point. I do want to get more done, though. Tell you what, to do the next steps, I wonder what silicon caulking looks like in my SEM. Don't even say that, monochroma. That is no. No. Okay. Probably a good mirror for a few seconds. Okay, so we're going to reposition the microscope because we're kind of done in this corner a little bit. You know what? It's been a while since I put the bits back in here. Let's do that real quick. Okay, got all of those too, I think. Yeah. We are missing a bit. Okay. Okay, so we're on the lookout for our smallest JIS Phillips bit. And the screwdriver handle. So that's probably where the bit is in the handle. Well, here's another thing. It's okay, not that. Okay, flashlights. Let's get those out of there. Don't need that on there. Let's get the lens out before we tilt that accidentally. Good brain rot. Good brain rot to have. Oh, the fiber optic cable. We're dealing with that now. Okay. Hey! I found the screwdriver handle and the bit. I was like, oh, I'm missing a bit. I wonder where that is. Oh, fried cabbage. That sounds delicious. For some reason, I bet Maria would like that too. Okay. Okay, so let's add. Okay. So we're gonna work on this CAN cable now. So this is, notice how there's no red, so all the, almost, okay, you can kind of tell the difference. These red cables here, those are fiber optics, those are all fiber optics. There's a slightly different color of reddish, that's a heater cable for the bake-out heaters. We don't care about those ones. Notice how there's just this one random fiber optic cable just like sitting on the bottom of the microscope. That's not supposed to be there. It's not supposed to be like that. Okay, so we're doing this. We're gonna position some lighting for it. Where's the release? Why can't I find the release from this side? There we go. There we go. So why don't I like this the way it is? I think I have some good reasons to not like it the way that it is. And it is, my concern is for the cable as we open and close the door. The current routing is putting an awful lot of strains in places I don't want it. Yeah, famous last words. That's not supposed to be there. Salt and pepper sounds pretty good for that. Okay. So this here used to be the cable for the stage. I don't know why it was abandoned. Let's just try shining some light through it and see if something's obviously wrong with it. These are slightly fancier connectors than I use most places on this microscope. So I'm guessing that that's the other end that's disconnected right here. Come on, flashlight, you can do it. There we go. Okay, so I don't know if you can see that on camera. So that's definitely one of them. That's the other one. Those are both pretty bright. So I don't know. I don't know why they would have swapped it like this. 346038-9004, 34953. Okay, so they're slightly, 346038-9004. Okay, so they got the same number on them. Or one of the numbers is the same. Okay. B1, B2. Let's pull those plugs out. We got these nice dust caps here. We're going to use those. Okay. How do I want to do this? I know what I want to do at this end. This end's not that hard. This end's going to be pretty easy, actually. It's the other end I don't quite know what I want to do yet. Okay. Just gonna follow the original, I think. Not seeing any reason not to. Hi, everybody. I love being inside microscopes. It's so much fun. I've worked on microscopes where I've been inside the actual chamber. Like the like that's how big the chamber was. That like I was in it. How does this cable tray work? Okay, I see. Okay, got that in. Needs to start. I don't think I looped anything in I wasn't supposed to loop in. That is an interesting theory. I think CAN communication issues probably show up a little bit differently than limit switches. It was not. It was a. It was 835, 1235. So dual beam, columns on the outside, big chamber. It was not that one SEM that has the column mounted on a 5-axis like arm, like the whole column. It wasn't that one that has the whole column in the chamber. And you look at like an entire car door or something. Okay, I think I can just barely reach where I want. Yeah, I can. Cool. Okay. So where am I pulling it out of? Where am I pulling it to? Ow. God damn it. Gentle bonk. Okay, we're going to that corner right there. I can do that. No problem. Come on, come on, come on. Okay, we're getting close. I'm not really working where I thought I was going to be. Probably should reposition the camera slightly for y'all. Come on. What am I getting caught on? Oh, sorry if that was loud in your all's ears. Hey, look at that. There we go. Okay, let me make sure I got the twist the way I want it, because the twist on the door part's going to be critical to get set right, so. Okay, I'm happy with the twist over here, I think. I have heard of E-beam welders that work that way, and they are water cooled. This is just an SEM column. It's just an SEM column, you know, yay big, and you can just like move the SEM column wherever you want, so you can image a massive thing in the vacuum chamber. I think they had it, the whole thing at M&M one year, actually, too. If I'm not mistaken. Okay, I am happy with the twist. That wasn't that hard. It does make me wonder why it wasn't put in before. Like maybe this way of it hinging is actually bad for it. I don't think it is, but. Okay, let's do B1, make sure it looks clean. Do look clean. I think we want to zip tie this right here. Just to minimize the number of times that this flexes right here. Yeah, we're gonna zip tie this into the bundle right here. How's that look, y'all? What do you think? Yep, the VizTech microscope, that's it. Yeah, isn't that thing cool? I almost want to put some kind of like rigid support in. I really want it rotated like that. Right like that. Something to strain your leaf more right there. Well, it's going to be clear somebody did something to this cable, but that's not bad because somebody did something to this cable and it didn't start with me. Very curious why this one was taken out of service. Go ahead and throw a link to that VizTech microscope in, and Monochroma should be able to approve you posting a link, I think. That thing's pretty cool. I think other people enjoy checking it out. Okay, I think I like that. I kind of like how it crosses the bundle a little bit. Okay, I think that's gonna do pretty nicely. Let's see if we can kind of, oh, and I wasn't really pointing the camera at it, that's unfortunate. Okay, well, there's what we got. Let's kind of see what it does as we open and close the door, and then if we're happy with it, we'll snip the zip ties. Oh, it bends it, you see? I don't like how that bends. Do not like how this bends right now. So what happens is this whole thing kind of comes in some. So I got an idea. What if we do this? What if we pivot it higher up? How do we feel about this, chat? I like these cable clamps. These are cool. These seem like they aren't going to be exceptionally likely to break. Like a lot of other cable management solutions, once they get older, they just break. Oh yeah, that's barely moving now. Okay, okay. I think we have found our solution. I kind of want to, because once it closes all the way, we might this could maybe get pinched. So what I did, I guess I didn't show this on video very well. I took it out of this bundle on the left here and put it in this one on the right. So it's pivoting here now. It's just kind of rolling, and this way it's not moving a whole bunch at the bottom. So you see how at the bottom, this bundle here, it actually moves a fair amount. And so I was just watching this like bend quite a bit when I was doing that. But I like how it's handling the curve up top a lot better than I liked how it was handling it at the bottom. Okay, cool. So I gotta decide, do I want to come over these water lines, stay under them? I gotta decide what I want to do down here. Do I want to put this on the other side of those? I think I want to put this on the other side of those. Don't want to clamp too tight on these because these are the high voltage cables for the ion pumps. Oh no, I might have interference from the high voltage cable on my optical cable, you know, it might induce photons. I don't want that to squeeze unevenly on the ion pump cable there. So we're gonna go one loose like that. Yeah, that's gonna do it. Okay, I think the way that's routed now is gonna cause substantially fewer future issues. I guess that can just hang out down there. It's not being used. Or can I just clip it up like this? I actually kind of like how that goes in next to the ion pump cable there. Okay, that seems like a good place to tuck the retired cable. Or hopefully retired. Oh, weird. I don't get how URLs work in YouTube chat. Okay, I think we got our new routing done. Pretty happy with that. Cool. Hey, there's no fiber optics on the floor of this SEM anymore. We're doing great. Yeah, that's the article. I've read that exact article before too. I gotta check a box off. Yay. Okay. Okay. I want to look at these pictures real quick. If you all are here watching the stream right now, definitely check out the links that Meow No Chroma or Monochroma has been posting in chat because that's some cool stuff. It's a SEM that oh, it's a Mira X. So that's a test scan column, I think, right? This is the type of thing test scan would support, you know. So that is a Mira. Mira's a. Oh, Mira's a Zeiss column. I didn't realize that. I thought Mira. Why did I think Mira was a test scan column? That does make sense that they would throw a Zeiss in there. Oh, is Mira a thermionic Zeiss column? Is that what it is? I thought test scan had a Mira. Yeah, test scan does have a mirror. Right? Yeah, test scan's got the mirror. So why are they saying it's a Zeiss? Unless Zeiss also has a mirror. Did they just get the manufacturer wrong in the article that everybody always reads about it? I'm pretty sure the mirror acts as a test scan. I could be wrong. Oh, they're calling the... Are they calling the entire microscope a mirror? They're calling the entire microscope the mirror. Okay, I see. So the mirror is not the column. Because I was going to say, test scan has a mirror too. Got it. All the detectors and the camera and everything mounted around the pole piece is pretty fun. I don't quite understand what the worm gear dealio is. That's a cool microscope. Okay. Let's, yeah, okay. So we're at reposition the SEM now. That sounds like fun to me. Okay, let's get our lights up out of the way. We can close up a little bit. Yeah, you've got a spare column, mount it to your, put your entire CNC machine in a vacuum chamber and just use it like that, right? God, I really wish my rails came a little bit more this way, but I just gotta get like extensions for them or something. Why is this one being weird? I see why this one's being weird. Let me fix this real quick. There we go, not being weird anymore. Let's get this side closed up. I do really like having this set up such that I just like, when it's convenient, I just move the entire microscope, you know? Like, it's very nice. It makes it feel more like a microscope factory. I can't say I've routinely moved this microscopes as much as I do when I'm working on them in labs. Okay, we're gonna put that on a different tripod. Leave that one set up in spider mode on the floor. Right, check out how I got this tripod set up down here. I really like it. Floor is eating all the light. It is hard to get that exposed enough to see it. I love that tripod down there. That made it so easy to get the camera up close and everything for showing you what was going on in the scope. It's funny, like that's the correct exposure right there for the microscope, but it's not the correct exposure for the floor. It's not mounted on one leg of the tripod. It's mounted on like an arm thing that's on the tripod. Here, I'll do a quick demo of this tripod. So this arm is on its like own pivot, right? So it can like pivot around, right? And then I can also change the angle of this arm. And normally this is just like this. This is just the part that goes in the middle here. But it also like swings out like this, which is very useful. But now we're on a slightly taller tripod. Now we're on this one. And this one does kind of have some similar features, but it's not quite the same. Yeah, I really like these. These are Vanguard tripods. Big fan of these. I've had some older Vanguards too, and these are the newer ones, and they're even nicer than the older ones. Yeah, the live stream. The live stream is 18 seconds behind reality. I think that's round trip, if I'm not mistaken, right? So it's like probably 9 or something. Okay, let's get this door closed up. Oh yeah, I barely see that cable moving at all down there. I'm very pleased with that. How I've got that hinged now. Okay, so you would think, right? You'd think, oh, you put an electron microscope on the space station. You just use the vacuum of space on the space station. It turns out, when you put an electron microscope on the space station, you don't just use the vacuum in space for several reasons. So, funny story. I probably told this on stream before, but there was one time I loaned a sample of mine to a company that makes a very, very small little cute SEM. It's actually, it's really small, really lightweight, really low power draw, pretty cute microscope. So I loaned a MEMS gyroscope sample that I prepared to them because it was a cool demo sample. And like the microscope's not particularly high resolution. It's tiny. It's so I sent them this sample, and then they were like, "Oh yeah, we'll give it back," and then they never gave it back. And I was like, "Oh man, I kind of like that sample. That was a cool sample." And the sample has done really well for me actually, because that one's also ended up on the front cover of like a MEMS textbook. It's a cool sample. A few years later, I get shown a video, and it's there's an astronaut floating in front of an electron microscope, and they turn the microscope on, and the sample that's under the microscope was mine. So I got the first. So I prepared the first sample ever imaged by an electron microscope in space. So I'm like, okay, I understand now why you didn't send the sample back to me. That's okay. If you're not going to return something to somebody, like at least send it to the space station, right? So it's only polite. Okay, make sure we're not going to pinch anything. Make sure we're right where we want to be to pick it up. If you're a little bit off on this, it can kind of slide some after you pick it up, and then it like dips down a quarter inch or drops a quarter inch. We don't want that. So yeah, there is actually currently an electron microscope on orbit on the space station. Earth's magnetic field is wonky at orbital speeds. You do have to correct for that. That was it changes every 90 minutes. It's actually constantly changing. So that was kind of funny. Yeah. So the deal with vacuum on the space station is you share the vacuum line like you like with everybody else. Like everybody else's experiment can also just like connect to like the dump port. And if you are connected to that port, you're subjected to like a bunch of extra like regulations, and you have to like communicate with the spacecraft bus, I think, to like kind of handshake on like when you're gonna like do terrible things to the vacuum line. So the pressure can just like spike on you at random points, you know. So like it turns out that like for like practical and for bureaucratic reasons, it's like substantially easier just to like fly a pump to orbit than it is to just use space for vacuum, which I think is kind of funny. But so it just uses a pump instead of using the vacuum ports on board or on orbit. The bottom camera is kind of jittery. Was it autofocusing maybe? The exposure seems a little bit high on it at the moment, so let me drop that down. What about putting it outside the space station? That outside station is an option. It does make it harder to load samples. I mean, there is like the Japanese experiment racks outside the station. Okay, we have very gently placed this microscope. So now I can get the jack to the other side of it. Yeah, just pop one of the KF flanges off the wall, I'll be fine. Despite what it looks like, we are actually all the way through the frame. Are we picking it up where we want to be? Or are we on some weird edge or something? Okay, it's just my floor being weird. Which my floor is weird right here. Oh yeah, KF30. Yeah, I think station is at 11 psi. Which, if you ever send something to orbit, you should think carefully about that, because, well, Poseidon's law. Oh look, we're back to the email box facing this way. Not Poseidon, Poissons. Okay, make sure I got enough room for my tool cart to fit. I do. Am I centered up on my camera pretty much? Now we'll swing it a little bit more this way, I think. Oh, and chose a great time to die there. That looks pretty good, I think. Cool. And it is kind of sticking out into the eye a little bit, actually. That is kind of the nature of the part the microscope we're going to be working on. Okay, I think I like that better. Yeah, let's do that. Placing the microscope nice and gentle. Well, I think with that, we're gonna pretty much be wrapping the stream up here. Well, pretty soon, actually. We'll take just a gander at what we're gonna be working on next. But this has been a great stream. I've really appreciated having you all by for it. I'm not quite done yet, but I don't think we're going to seriously tear into what comes next here. I think we're going to save that for next time. Oh, it looks like we lost the camera. Yep. And we're back. Okay. So this is where we're going to be working on the microscope next. Let's bring a light over. Did I do it again? I did it again. Sneak peek. Sneak peek for next time. So that right there is the, I believe that's the dynamic driver board. So it's got pretty much the same heat sink that the same heat sink as the stage driver. And down at the end there's those little blue wires for a temperature sensor. So yeah, we're gonna be working our way through this thing. Again, I suspect that this thing's gonna be in pretty decent shape because it's water cooled, and so it's gonna have probably not overheated our capacitors or anything of that nature, which is awesome. And then on the other side here, which is accessible, which is, these two kind of have to stay together because of the length of these like tubes on here. On the other side here, this is, I believe, the static one, because there's not very many static lenses in this microscope. So yeah, that's these are our electron optics drivers here. And this is what we're going to be doing next time. So much fun stuff. So fun. Man, there's a Xilinx in there too. And there's a lot of bodged together capacitors. So that'll be cool. So yeah, we'll do these two, then we're gonna do these two. So this is our scanning one, scanning and detectors. So that box will be interesting. And then we got this box here, which is our kind of our hardware controller. All the CAN goes to this box. And I really love how the rack kind of works on this, where it holds itself out when you pick it up. You know, I think it's pretty cool, the service access in this microscope. One of the better service access, as far as microscopes I've worked on go, this has definitely got one of the better service accesses on it, I think, personally. So yeah, that's what we're looking forward to tomorrow on that. So yeah. So that's sneak peeks. Oh, that was a 5-hour stream. Cool. Well, if y'all got any other questions, now's an excellent time to throw them in the chat because we're going to be wrapping this one up here pretty shortly. It's been great having y'all by. And if I want to be a real YouTuber star, I should say, like, click the like, thumbs up, subscribe. It helps out a bunch because it actually does. That little heart button in the chat probably helps out a bunch too. So yeah, let's see here. And also, welcome to those of you who just joined the various Discord servers. And then be sure to ask for a channel for your SEM and introductions, and they'll get you one set up. So yeah. Well, I think with that, we're pretty much going to wrap it up. Seriously, you guys have been, this has been one of my favorite streams so far, and I can't wait to keep it going. I think with that, I'm gonna see y'all next time. Y'all have a lovely evening, morning, midday, mid-afternoon, whatever it happens to be in your part of the world. And with that, we're gonna see y'all next time. Bye!